sure that everybody can see my screen and you can hear me okay, you can just put a thumbs up on the chat, or you can say a quick yes, so I can make sure that everybody can see the presentation and you can hear my voice okay. Perfect. I got one yes. Thumbs up. Awesome. Awesome. That's a good thing. All right. So I'm going to be your instructor for this CCNA 200-301 certification course. As we know, this certification brings a lot, and we'll be discussing all the different domains and topics that it has in it. But a little bit about myself first. I've been doing this for over 20 years. Not only am I a network engineer, but I am also an educator. I've taught in technical schools, I've taught in career colleges, community colleges, universities. I'm an author. I've authored 2 books, one for the previous certification, CCNA 200-125, as well as a book on IPv4 and IPv6. So I've been teaching CCNA 200, or the CCNA itself, for 20 years. So I know a lot of the tips and tricks and how to get around the certification, how to answer the questions, what is it that you're looking for. So I have a lot of experience. But my main thing, my methodology in teaching is learning through labbing. There will be a lot of labs in this particular course. We must understand the concepts, but then we need to apply those concepts into a real world scenario, but also other types of scenarios, because you are taking a test. You are taking a test, and the test is different from real world. Okay, so I want to make sure that the topologies that we're working with, you will get that. So that's one thing about me. Since I've been teaching this for a very, very long time, you will be very happy, okay, once we start doing all the hands-on. So that said, what can you expect? Well, as you can see right there, I mean, you can read that for yourself. If this gets you ready to master, and you will master, the fundamentals of networking and ACE, we hope, the CCNA 200-301 certification exam. Now, this course is designed to prepare you for real-world networking. It is, because every configuration that we're going to do, it's what you do out there. The only difference is that you don't have 1,000 people that you're troubleshooting because they're making all sorts of errors. But we will be, I will on purpose be making errors and then say, hey, what happened? We need to go ahead and fix this. So there's a lot of things that we're going to be doing that's going to get you ready, because that's our goal as well. Our goal is not only for you to get your certification, but when you go for your interview, when they test you out there in the real world, in the job, that you can perform. You need to be able to perform, not just pass the test. All right. So you need to expect in-depth coverage of key topics, including IP addressing, routing, switching, security basics, and troubleshooting. Now, let's slow down a little bit. And when it comes to right here, so you can see where I'm looking at, right here, I don't have a steady hand as some other people. All right, IP addressing. I'm sorry, Indra, you had a question? Okay. All right, so IP addressing, obviously we're going to cover IPv4 and IPv6, 2 different types of addressing. IPv4, we've had it for a very long time. I have a nickname that follows me, which is called the IP Master, okay? The book that I wrote, okay, on IP4 and IPv6. So I'm going to show you a very, very, very easy method of troubleshooting or subnetting, route summarization, VLSM, when it comes to IPv4 addressing. All right, IPv4 addressing, it is crucial. I look at, this is the kryptonite of every IT person out there. They have an issue with IPv4 addressing, and it's not their fault. Once you get into the real world and you have a particular job to do, you put in an IP address and then you forget about it. You never again subnet. You don't do it on a daily basis. So, but then what happens? You need to get certified. And now you got to go into a testing environment which you're going to have to do things. And ladies and gentlemen, calculators are not allowed inside a testing center. So you need to be able to do this in your head. You need to be able to do this quickly, with a piece of paper and pencil, which is given to you, or in your hands. And that is my method. IPv4 dressing, I will make it so easy that you can go ahead and do it in your head after you practice several times. And IPv6 will also be there. You'll need to identify IPv6 addressing. So this is a key topic that we're going to drill down a little bit as we go through the presentation. Routing, you need to know your protocols. RIP version 2 and RIP-NG, both right. RIP version 2 is for IPv4, RIP-NG is for IPv6. EIGRP for IPv4, EIGRP for IPv6. You need to know this. And you need to know OSPF for both, OSPF v2 and OSPF v3. It's not as difficult as you think. And again, I put things in very easy to understand methods, and I reinforce it by using labs, which we'll be doing a lab today with those two protocols, RIP and OSPF. Now, who should enroll? Now here it says, to solidify your network and all your understanding, anybody can enroll. As long as you have some computer basic knowledge that you know your way around an operating system. And in today's society, everybody has some basic computer knowledge. But let's say that you've never, ever touched a router or switch or anything like that. That's fine, because I will take you from zero to hero. I will take you from the very basics of what a router is, what a switch is, what a hub is. And honestly, a hub, I'm not going to mention it that much because it's not in the test and it's not anything we use. So switches and routers are what we're talking about. And you talk about layer 2 switches, layer 3 switches, which are multi-layer switches, and then the routers. That is what you'll know. But I'm going to teach you from the ground up. So it doesn't matter if you've done this before or not. It will be more helpful if you've done it before. Sure. You say, hey, I heard that before. I know, I've seen that configuration. I've seen this router. I have more or less an idea. But let's say you're brand spanking new to this. That's fine. No problem. But one of the things that you need to do, and I expect you, says here what to expect. I expect for all of you to be asking questions when we're inside the course. This is not a silent course. This is a two-way street. I will give you the information. And if you do not understand, I expect you to go ahead and ask to understand what's going on. Okay? So please do so. Ask all sorts of questions. So again, it doesn't, to me, or I believe to us here in the Networking Kings, as long as you have the desire, the passion, the will to burn that midnight oil to accomplish that goal, you will accomplish it. And I will do my 1000% to make sure that you do accomplish that goal. All right. So three key areas that I want to talk about, because these are the areas that usually everybody falls short. Now, I've already told you about IPv4 and IPv6. I know that IPv4, again, we've been using it since the dawn of time, but IPv4, ladies and gentlemen, is dead. Okay, it is dead. It's been dead since 2013. I think the last public IPv4 address was given out from the AFRINIC in 2017. We have no choice but to transition to IPv6. So will you be configuring IPv6 with me? Most definitely. Will you be configuring IPv6 in your certification? You just might, because there's over, 100,000 question bank that exists that they can pick, or more, that they can pick questions from. So you need to be ready for whatever is coming your way. And I'm going to make sure that you're ready for whatever is coming your way. So that's why we're going to configure both IPv4 and IPv6, and that is considered a dual stack scenario, which in the real world, a lot of people, they're transitioning over to IPv6. They need to be able to configure IPv6. So I understand that IPv6 is a weird IP address to look at because it's hex numbers, it's 128 bits long. and you're like, oh my God, this is so long. It's okay. It's okay. And once I show you, you're going to see how easy it is. And the routing protocols, the ones that I just mentioned, which is RIP version 2 or RIP, EIGRP, and OSPF. In all honesty, EIGRP in your exam, in your certification exam, is very basic information that you're going to run into, that it uses bandwidth and delay, that it uses autonomous systems, the EIGRP topology, things of that nature. But what we're going to do, IPv4 is 32 bits, yes. And how many bits is IPv6? It's 128 bits. 128 bits. All right, that's how long it is. And they're hexadecimal numbers, and they're separated by a colon. All right. And in IPv6, just to elaborate further on that question, is that IPv6, it's not called a subnet mask, it's called a prefix length, Even though we use the same terminology in IPv4, but we usually are used to saying CIDR notation, right? Or we're used to saying subnet mask. Now, with the routing protocols, I was speaking on EIGRP. EIGRP, just to talk a little bit about it, EIGRP is considered the advanced distance routing protocol. It's a hybrid protocol because it borrows things from RIP, which is a distance vector, and OSPF, which is a link state. And the RIP and OSPF is what we're going to be doing a comparison on. EIGRP is a Cisco proprietary routing protocol, and it is based on autonomous systems, but it is limited only to Cisco equipment. I know there was a writing back in 2013 where they stated that they opened up EIGRP for other vendors. That didn't work so well. That did not work so well at all. Okay, so EIGRP, only Cisco. But EIGRP, let's say you're working in a company that all they have are Cisco equipment. You're going to use EIGRP. If you use EIGRP, know that there's a maximum hop count. By default is 100. The maximum hop count is 255. So there's your limitation, one of your limitations. The other one is only Cisco, but it uses a different algorithm. Every one of these routing protocols uses a different algorithm. RIP will use the Bellman Ford.
Okay.
Samir, you have a question?
No.
Okay, so okay, no problem. So EIGRP is based on autonomous systems. EIGRP does pay attention to bandwidth and delay. There's a lot of things that EIGRP uses, but again, it's limited to that 255 hop count. All right, but it does use something called K values, which is another thing that they're going to ask you definitely in your certification. What are the K values for EIGRP? And this is the reason why I'm going to go over EIGRP. But the big difference that what I'm going to give you, that what's not going to be in your certification, but I'm still going to give it to you, is the configuration, because it's just that simple. Because once you go on your career path, which I'm going to show you a map, a Cisco map of your career in networking, when you get to the CCNP designation or concentration level, you're going to need to know how to troubleshoot that. And if you, as a CCNA professional, are hired to work at a company that's using Cisco equipment, and they may just be using EIGRP, you need to know how to configure it. In the lab packet tracer, that is correct. Do we configure IPv4 or IPv6 addresses? Both. You will be doing both. We'll be doing something called dual stack. So I'll have both addresses on there. You need to know how to do both. No big deal. All right. But one question that I always like to ask the students is, you're working at a company, it's a brand new company, all the equipment is set up, and now you have to make a decision that you're going to do dynamic routing. Which is the best routing protocol to use? Which is the best routing protocol to use?
OSPF.
Why is that, Sanjeet?
Sorry, OSPF has more functionality. It's the best routing protocol according to choosing the path. It's short, like it chooses the shortest path. That's why with the high band, with the less traffic in the route, and that's why
You think it's the
it has
best?
more security as well than OSPF.
Okay, so OSPF is a very good routing protocol. It's not bad.
Sorry, then
It
EIGRP. I apologize.
no, I know, I understood. And then EIGRP, but every routing protocol has authentication within it, where the routers can authenticate within themselves. All right. And when we talk about security, we can talk about IPsec, which we'll be configuring on the endpoints. If you're going to be doing tunnels, like say a basic GRE tunnel, we can go ahead and do IPsec on either side. Now, the reason why can't we do EIGRP? It has authentication. It does pay attention to bandwidth and delays. And it's not because OSPF has a limitation. OSPF has a limitation in the sense of that you must have an area 0. And area 0, all routers must connect to area 0. Because if you have area 1, area 2, area 3, area 4, now you're not going to be able to connect. There will be no communications between routers if you just have area 1, 2, 3, 4, 5, 6, all the way up to the 4.3 billion areas that it can have. EIGRP doesn't have that, right? So OSPFs have something called a backbone area. So there's a limitation. And I can tell you, so to answer the question, what will be the best routing protocol? My response would be, well, it all depends how complex your network is. How much redundancy do you have? How big is your network? So for big networks, complex data centers, ISPs, OSPF core type routers, they will use OSPF at the moment. But when you're looking at data centers or ISP, guess what routing protocol they're using? They've been using ISIS. And if you look, I don't know which books that you guys are using, but if you're using the, well, really all of them, you have it. When you're talking about software design access, Cisco is getting rid of eventually, not yet, eventually Cisco is getting rid of spanning tree at the distribution access layer. And they're getting rid of the redundancy protocols at the distribution access layer. And everything is going to be multi-layer switches, or layer 3, as we normally call it, layer 3 switches. We're going to be routing at that layer, and the protocol of choice, as per Cisco, is ISIS, not OSPF, not BGP. So which routing protocol is the best? It all depends on your network. That's what you need to think of. Because you have a small network, why would you? Because OSPF is very burdening. So not to get into more detail, but it's very burdening with OSPF. So there's a lot of things that you need to think about when designing a network, when choosing a routing protocol, a lot of variables that you need to take into consideration. Okay. Now, somebody put it here in the chat. I hope I answered your questions. So Samir, I hope I answered them. That you struggle with IPv6. You and the rest of the world struggle with IPv4 and IPv6. That's okay. That is fine. The method that I'm going to teach you with for IPv6 is pretty much the same as IPv4. And the way I break down IPv6 is going to be so easy. I'm going to show you a couple of examples here in a little bit. It's going to be so easy. You're going to be like, no way, Laz. It's that simple. It's that simple. All you got to do is just get your mind saying, hey, this is IPv6. No big deal. What do I need to focus in? That's it. That's all you got to do. What you need to focus in. But I'm going to show you a quick little glimpse into IPv6, and you're going to see how easy that's going to be. The third key area where I notice students having a lot of issues with is access list. And we're going to be doing both. We're going to be doing IPv4 ACLs, and we're going to be doing IPv6 ACLs. Can anybody here tell me the difference with IPv4 and IPv6 ACLs? Just a high-level overview. All right. So with IPv4 ACLs, you have numbered and named, right? For standard is 1 through 99. For extended is 100 through 199. And then you have standard and extended, correct? Yes, you have both. But you also have named ACLs, right? But with IPN, the way you apply it to an interface is IP access group, the number of the ACL or the name of the ACL and the direction. With IPv6, there is no standard or extended ACL. And they're all named ACLs, which is great because once you do named ACLs, there's more granularity when you're doing it because now you can control the sequence number that before in a numbered ACL, you cannot. You will have to redo the ACL and then copy paste it back into the router. So we don't want that. We want to have full control of the ACL. And the way we do that, if we're in IPv6, is through the sequence number. Okay, and I'll show you examples of that. Well, we're going to be doing a lot of labs on that. So you can get accustomed to looking at the ACLs. So this is one of the key topics that I see a lot of students having issues with. All right, but there's a lot more topics and we'll get into the different domains of Cisco in a bit. Okay, so topics here, IP4 subnetting, and I'm going to show you that right now. And then we'll do RIP and then I'll do a standard ACL. I'm going to open up Notepad, okay? And let me know if you can see it. Can you see this? Oh, what is all this? I must have written on there. Can you see the screen? Just give me a thumbs up. Give me a yes.
Yep.
All right, perfect. All right. So let's say this is an easy example. The way that I do it, I don't care about this. I care about this. I care about the mask. All right. So this is a 224. My focus is the fourth octet. Do you agree? This is where, because this is all full, because the maximum value of any given octet is 255. So what do? I do my little graph. First of all, 128, 64, 32, 16, 8, 4, 2, 1. What is this? What are these things called? What are these numbers? What are these values called? Bit values. Those are your bit values. There are the bit values. There's 8 of them. So those are the bit values from left to right of every octet. They're the same. So what I do is I go x.x.x. Oh, let me put it in capital. x.x.x.x. They're all full. 255, 255, 255. 224. 1, 2, 3. 1, 2, 3, 4, 5. If you were to add these 3 right here, that's 224. So what does this tell me? What does this tell me? This tells me that my network is incremented by 32. Okay. And then if I were to add these up, right? If I get the sum of those bit values, because that's where the line is at, what number is that? If I add those up, 31. I didn't add that up. 1 less. You can add them up. I don't want to. Why I don't want to? Because I need to be quick to answer questions. So that's 31. So what do I use this number for? To calculate broadcast. And it's your wildcard mask. Okay? So they gave me this network ID. Let's bring this up. Right? So they gave me that network ID, 192.168.1.0. We're using this mask. I'm going to get my broadcast address. Okay. This is the number I used to calculate for broadcast. 31 on the 4th octet plus 0. What is it? 31. 192.168.1.31. So what's my usable range? Well, what's after 0? 1. What's before 31? This one right here. 30. These are the addresses that you can assign to your end devices. That's it. That's all there's to that. We're going to be going in depth in all this and have tons of questions on all this. But look at this. So it says it doubles to get my wildcard mask. Well, 0, 0, 0. 0 means match exactly. 31. There's your wildcard mask. So there you have it. Okay. Doing it this way, you're going to be able to answer questions in 10 seconds, in 15 seconds. And if you practice this enough, which you will with me, if you practice this enough, you will be able to do it in your head. You'll be able to just look at the mask and say, oh, it's incrementing by 16. Oh, it's incrementing by 32. Here, your bit values are your incrementations per octave. So you got to be careful which octave you're working in. So I know I'm incrementing by 32. Boom. Okay, one less, 31, and then you increment. Subnetting, it's not difficult. All right, and I'm going to make it easy for you. All right, what's the next one? RIP. Let's open up the lab. So here we have a lab. Okay, give me a second because this red line is really annoying me. I need to get rid of that. Can I get rid of that? No, I can't get rid of that. Okay, well, we'll just deal with it. All right, so we have here 3 routers. Okay, and for somebody that said that they're struggling with IPv6, I'm going to show you as well. But let's do IPv4. So we got a router. It opened up in the other screen. Let me bring it over. It's very easy. Now, I'm going to be giving you a lot of handouts for configurations so you can practice. All right, we're going to do enable, short. You are able to, you don't have to type enable. You can do this in your certification. That is fine. Conf T. And I always like to do the host name. You can tab. You see me tabbing a lot. R1. And then I'm going to go to interface, G0/1, IP address, 10.1.1.5. Y5 is assigned to 30, 255, 255, 255, 252. No shut. Now, I'm going to configure RIP right here and now. So I'm going to exit once. I'm going to do it from global configuration because you need to understand what prompt you're in, and you will. Router, RIP, we're using version 2. Nobody uses version 1. Okay? Version 2. And now this is considered a class full routing protocol. This protocol used to be where, well, the way you do it is by typing the class full boundary. I'm going to prove something to you. The class full boundary of this class A address right here is a CIDR 8 or a 255.0.0.0. That's the class full boundary. So even though I would put this, oops, sorry, network 10.1.1.4, that's a problem. And what's that? It's a problem. It's going to summarize it to 10.0.0.0, and I'll show it to you. So one of the things that you need to do, and this is a troubleshooting command, we're doing a lot of troubleshooting as well, do, and the only reason I'm doing do because I'm in this particular prompt, do show IP protocols. Okay, let me maximize this so you can see exactly what I'm looking at. Look what it says right here. Automatic network summarization is in effect. What does that mean? That means that if I don't type this, okay, give me just a second. I don't know what happened here. Okay. Oh, somebody put in there. We will learn to configure stack switches as well as like stack of 2 switches or 4 or any number of switches. We'll be configuring, not using the stack wise, making all, let's say 6 switches as one, but we will be configuring multiple switches. Yes, we'll be configuring 4, 6 different types of switches, layer 2 and layer 3. We will. All right, because we need to do either channel. We need to do either channel. All right. What was I showing you here? Oh yeah. I need to type no auto hyphen summary. All right. If I don't type that, let me maximize this again. You're welcome. If I don't type this, this will still be enabled. It will be in effect. We don't want that. Once I type auto summary and I'm going to up arrow. I'm going to do the same thing. Look what it says. It's not in effect. You got to make sure of that. So these show commands, and I'm going to give you a handout with show commands. It's very important that you look at these things. Show IP protocols, very good command, because you want to be quick to get to where you need to go to find out what's going on so you can fix the issue. All right. And what does that do? What does that do? But before we get there, check this out. I'm going to do a run command, which you don't need to do in your certification, but just to get to the root of it real quick. Show run pipe section, I think router read. I'm better one. Or route. You can see that I didn't put that. I put 10114, but RIP summarizes it anyway. That's why you cannot forget to type that. You cannot forget to type that. Or else everything's a 10. When it gets out there, the subnet mask, the updates doesn't send the subnet mask information out. It won't know where to go. It'll get lost. It may get there, it may not. So that's something that they will gig you on the test. They will reduce, they will take, that will be a wrong answer for that question, and you don't want that. So let's configure this one real quick. For the one that asked about switches, definitely when we get into span tree, VLANs, and all that, we'll be doing a lot of switching. Whole name R2, put it in caps. All right, interface G0/2. Oops. IP address 10.1.1.6, 255, oops, 255.255.255.252. No shut. And then interface G01, IP address 10.1.1.9, 255.252. And don't be concerned if you make any mistakes. If you make mistakes, I make mistakes all the time. Typos, that's fine. That's how you learn. It's okay to make mistakes. What did Einstein say? What did he say? He said, I failed. I didn't fail 1,000 times. I just found a way not to do it 1,000 times. Okay? So that's okay to make mistakes because that's how you learn. All right, let's do RIP now. And now the reason I was back in privilege mode is because in just typing exit, I typed Control Z and it took me back to privilege mode. All right, and then we're gonna do router. Get this I-beam out of the way. Router, RIP, version 2, network. We're attaching 2 networks, aren't we? But, oops. All we need to do is this, because that's what RIP's gonna do anyway. But we can't forget that in auto summary. And I do WR, which I know I shouldn't be doing. We can type end, and it'll take us back to first mode. I'm going to do a copy, run, start, which in your certification is what you need to do. Copy what's in memory to what's in non-volatile memory. Hit enter, and that's the file that you're going to be saving it in. That's the default. That's what's inside the brackets. All you got to do is hit enter again, and you're good to go. All right, and then we're going to do the last one here. And again, it'll open in the other screen. Whoops. All right, so we're going to come here, enable, FAT, host name, R3, and then we go interface G02. We'll do IP address, and then we'll say 10.1.1.10, 255, 255, 252. Oops, we got 1 octet. And then no shuts. Then I'll just exit once. Router RIP. Version 2. And then network 10.0. Can't forget, auto summary, WR. So once you have that, now from this router right here, let's open this up all the way so you can see it nice. Let's take a look at the routing table. Show IP route. So these show commands are very important, but you'll have them. I'll give them to you. So it's not doing it for some reason, and I just did it too quick. One thing great about the packet tracer is the fast forward button. Has a lot of bugs, but that's okay. Let's take a look over here. Enable, show IP route. And you can see RIP right here already. R, this is your routing table. These are, and someone got a question like this in the test that they'll say, what is this? What is this called? What I just highlighted. They're called legend codes. All right. So they may ask that question, believe it or not. All right. But here, when you look in your routing table, if you're doing the routing protocol, it asks you, based on the following output, which routing protocol are you using? Well, I'm using RIP because it's a letter R, and that's what RIP is, R. So can we ping? Ping 10.1.1.9. And again, I don't like waiting. I always get away, but again, that ARP can get away from it in IPv4. And then let's ping 10. That's the way to the other side, the last router. And we can. Let's go to that last router where we didn't see RIP. You saw that we're able to reach it. Again, show IP route. There's RIP right there. Sometimes it takes time. So be patient with RIP. But I want to show now, real quick, the IPv6 address. Okay. Well, I'm not going to show it to you here. I'm going to show it to you in Notepad, just so I can break it down for you. I know I was going to use a standard ACL, but I want to show you that IPv6 real quick. It's not a big deal, but I really, 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 really want you to know that this is not crazy. So you have 2001, 3200, cafe, 1000, colon, 0123, 4567, 898, hex numbers, B, C, D, E, F. So let's separate this. This is the network prefix. Let's put it together. This is the interface ID, okay? And then you have your prefix length. Now, let's move this over a little bit, okay? Now, this one right here is going to be, not CIDR, prefix length of 64. This is 128 bits. This means that the line is right here. It's separating the network prefix between the interface ID. What do you need to know? Where are you going to be concentrating on? Let's go there. This hextet right there. This hextet is for subnetting. 2001, you can't mess with it. This is your RUR, or your, okay? Or your ISP, or whoever's going to give you this. 3200, this is your ISP. Well, you can't mess with the 2001, that is your 3200 is your ISP. Cafe is your company. And lastly, the 1000 is your subnets. You have 65,000, oops, 65,536 subnets available to you. How many do you have here? I'm just going to put the book says, your RUR says 18 quintillion. We're just going to put 15 quintillion. I think that's enough, right? 15 quintillion addresses per subnet. That's it. You're going to be working in here. And remember, each one of these numbers is 4 bits long. Okay? But when we get there, you'll see it. It's not difficult. It's not difficult. If you follow my methods and you practice and you ask the questions, I guarantee you will learn this without a problem. Without a problem. Okay? So this is IPv6, the very basics of it. Okay? The rest of it, as far as certification is concerned, is going to be identifying a global address, a unique local address, a linked local address, all the rules of serial, things of that nature. Okay? But this is it. This is it. And just so you know, that this is what your internet registries tell you to use in your LANs. But we won't go there just yet. All right. So standard ACLs. All right. Again, let's go back to the notepad. Very easy to do. Let's get rid of all this gibberish. In IPv4, a standard ACL, how is that? Access list. One. Let's say deny. Let's say permits. When I say deny. Deny host 192.168.1.1. It's very generic. It's very generic. You can only use source addresses. So what that's saying is, hey, I'm denying this host. But there's an implicit or invisible deny at the end. So if I'm just denying that host, I have to write access list one permit any. If I don't, everything is denied. Now I created this on a particular router. Where do I need to place it? Nearest the source or nearest the destination? Who has the answer to that? An access list, a standard access list, is it nearest the source or nearest the destination where I apply it? Come on.
I think it's a destination.
Correct. Nearest the destination. Because it's so generic, I just say, I deny you. You deny me from what? I'm denying you. You got to go all the way to the destination. It's either going to be in, depending on where you want to put it, but according to the book, it's nearest the destination. So you put it, let's say, on the interface going out towards that particular land, and the direction would be out. So nearest the destination. Now that's a standard access list. You can also, if you want to do an entire network, let's just put it underneath. For the same, I'll do a same type of access list. Access list. Let's say 2. Deny. This time I'm going to deny an entire network. 172.16.0.0. But now we use a wildcard mask. 0.0.255.255. And then we have to put that permit statement. Any source, any destination. So accesses are read from top to bottom. From top to bottom. So anybody from this network that comes in to the router, because if this is placed at the destination, this is placed at the source. And I'll get back to that in a second. But anybody with these two octets, because that's what 00 means, match exactly. These are any, or as they call it, the I don't care bits. Anybody comes in with a 172.16, they're going to be denied. Now what happens? They're not going to make a match here. They're going to go to the second ACL entry. And they're going to say, oh, you're 172.17, you're permitted to go through. You're 172.31, you're permitted to go through. It'll make a match here because they're read from top to bottom. Now, the last type of ACL, it's an IP, a named ACL. IP access list. I gotta do it in the router. I forget sometimes. Let me just do that so I can use my little handy dandy question mark. And you better do the same. You're not gonna know everything by memory. So question mark, you're gonna be able to do. It happens. It happens. IP access list tab question mark. Oh, okay. I want to do it extended. All right. What a word. Don't use a number. A word. Block underscore last. Obviously, it's not going to be that. Okay. Now you're in extended named access list. What do you want to do? Question mark. Well, there's your sequence numbers. You can put them. So you can put a sequence number. Let's say, well, by default is 10. Let's put 5. Okay. Sequence number 5. I want to deny a bogus host. This is just an example. Deny the protocol, in this case TCP, to host 1.1.1.1, source to this destination 2.2.2.2 that equals 80. And then the next one will be sequence 10. You'll do permit IP any. All right, let's save that. Let's do show IP. Let's do show access list. And there's your access list right here. There's your sequence numbers right here. So what I was talking about granularity is the fact that if I say, oh, wow, I forgot to add another network that I'm going to deny before it permits it. Well, I can go back into the same access list and then go ahead and put a sequence number of 7, and it'll come in between those two. That's what's so cool about the named ACLs, and IPv6 addresses are all named ACLs. All right, there's no such thing as extend or anything like that. They're all IPv6. So that's an ACL. The syntax is not difficult. What's difficult is the logic, understanding we're going to apply it. One of the labs that we're going to do is a very famous lab that got everybody because it goes outside what the book states. Okay, you got to think outside the box. So when you're doing these questions, keep an open mind. Don't just say standard, destination, extended, source. Think outside the box, see how traffic is flowing, and you're going to say, okay, this is where I'm going to put the actual access list and apply it in the right direction. Those three topics right there. Now, when I say I use RIP as an example, but routing protocols themselves, that's key. That's key. You need to understand that. All right. You have any questions before we go on to this? Any questions so far you want to ask? Okay. So objectives. Obviously, we're going to master networking fundamentals. We're going to do a lot of hands-on labs, exam-focused training, because I do need to cover the topics that are going to be in your exam. I'm going to copy it. I'm going to do it as real world as possible, but also gearing it to the exam. Because in 20 years, I've seen all sorts of questions. And yes, I've seen all sorts of questions. I want you to have industry-ready skills, definitely. When you go, or you go back to your jobs, or you're trying to get a job, you're going to an interview, if they ever ask you for, do you have any experience? Yes, you do have experience. Yes, you do. You've configured RIP. You've configured all the routing protocols. You know IP addressing left and right. You know how to do ACLs. You know about span tree. You know about switch port security. Yes, you do have experience. And you can have a portfolio ready with not the packet tracer. You don't never say that. Yes, I've configured this series router. I've configured these things. So you do have experience. You have troubleshooted. You have done this. Never say you don't have experience, because you do. Because once you leave me, you will have experience, because you will find all these different things, just like spine and leaf and all that stuff. You will have the knowledge to do all these things. So can you go to a real world network and configure it? Most definitely, without a doubt, if you do the work. If you do the work, you'll be able to do it. All right. And expert instruction, I'm going to give you as much as I can. All right. But I'm going to show you the Cisco PDF domains real quick. All right. So here, oh, that's where it's at. Let me get rid of it. Can I get rid of it now? Oh, come on, man. Seriously?
I think it's on Zoom.
I need to zoom in.
No, I'm saying that it's on Zoom board, I believe.
Oh, it's on the Zoom board? Okay. All right. No worries. All right. So let's come in here. I don't want to draw. I don't want to highlight. How do you get rid of this? All right, just get rid of it altogether. Okay. So the Cisco exam. Okay. So these are, now pay attention closely. Domain 1, keep the math, 20%. Domain 2, 20%. That's 40. 25, that's 65%. 10%. And out of this 10%, you have no idea how many people come back with issues. Okay, it could be because of NAT. Here we have DHCP DNS. We'll be doing DHCP on the router. We'll be doing DHCP on the switch, and we'll be configuring the DHCP server. We'll be doing DHCP relay as well. All right, so you'll understand that. All right, and we will talk about QoS, obviously. All right, but a lot of people come back with a lot of problems with IP services. And then 15, where were we? 2020, what was it? Did you keep the math? 2020 is 40, it was 65. This is 75. And this is 90, right? All right. No, yeah, right. Yeah, am I right?
Yep.
90. So you got 90% security fundamentals, 15%, which is very simple. You're not going to be configuring radius. You're not going to be configuring certificates of authority. You're not going to be doing nothing like that. You're not going to be doing configuring IPsec. We're going to talk about these things. We're going to be configuring them as much as we can. All right. But definitely this one right here. Yeah. This one right here. You better know. And we will be doing it. All right. Because it's not hard at all. You better know it. So if you know these first domains, these first 5 domains, and you get them all right, you can maybe miss a few. You got 90%. You passed. You passed. Now let's take a look at the last. And this is the one that people find the hardest because this is new, right? 10% is automation because now everything is based on automation. We'll talk about the Cisco DNA. We will talk about the language, the JSON, the REST APIs. Puppet and Chef, I can tell you right now, the 0 questions on Puppet and Chef. All right, but you may be the lucky one that may have a question on it. So we're going to go over, and this is the last thing that we're going to touch upon is this. The very last thing that we're going to touch upon is this last 10%. Because the first 5 domains will give you a 90% passing rate. Okay, 90%. And I'm going to make sure that you know how to do everything in these first 5 domains for sure. And then this is more, there's certain things we can do, and other things we can't do is basically terminology. So having this, if you can download this from Cisco, okay, you can download this from Cisco, and you can practice the, you can see their domains and all that other stuff. But this is a lot of reading, a lot of memorization when it comes to this. But we will talk about certain things when it comes to this, okay? Because you do need to know. All right, let's minimize that. So those are the objectives. As far as the future of the CCNA, the CCNA, it's not going away. If anything, it's going to evolve even more, and I'm going to talk about that. The future of the CCNA certification continues to hold significant value in the IT industry. Yes, it does. We have now cloud computing, which is huge. Internet of Things, automation, also huge. Cisco updated CCNA curriculum to ensure IT professionals are equipped with the foundational knowledge in networking. That's the number one thing, networking. Because if you don't network, what are you going to secure? All right, security, number 2, and automation, aligning with the industry demands for versatile and skilled engineers. So you need to be able to know, at least to be able to look at, describe the language, XML, JSON, Ansible, Python. You should be able to understand those languages and what they look like, right? You need to, obviously, you need to know your CLI, your command line interface. You need to know that. You need to know those commands. This is why I'm going to send you tons of handouts on the commands. Okay, so you know, and I'm going to show you where to apply them, why you're applying them, and we'll be working in different simulators. I'll use Packet Tracer for the simple, very easy stuff. When it comes to other stuff that you need to know, I'm going to be using Eve and G, all right, which has real iOSs, a lot better iOSs that I can do more commands in those iOSs just to show you. All right. But getting your CCNA, this is a critical stepping stone in your IT career. It is. All right. This is passing the CCNA. This is worldwide. You go anywhere in the world and you have a CCNA certification, your resume comes to the top. And then you can prove it as well. You can configure as well. And then on top of that, you can answer questions. And my hope, my goal is to make sure that any IP addressing question they can ask you can answer it in your head. You can count it in your fingers. That's my goal. That's my goal. And I want to accomplish that goal because we're going to get focused. This time that we're going to be together, it's us. It's all about us. And it's all about this certification. And you will learn this. All right. Now, What can you expect after this course? It's not over. In IT, nothing is over. IT is an ever evolving animal. Things keep changing